Welcome to Rethinking Resi. I'm Isabel Allen, Editor of Architecture Today, and I'm your chair for today's online conference. The day is divided into 4 parts. Part 1 is on innovative delivery models and is brought to you in partnership with SIG. Owen Phillips, Design Director at Legal & General Modular Homes, is going to tell us about the company's ambitions to disrupt the way traditional housing is delivered and talk about the tension between standardisation and the need for choice and diversity within the housing market. Connie Yachinska from Procter & Matthews is going to be presenting the Vaux Living Project, which uses modern methods of construction and low-carbon technologies to deliver the first phase in the transformation of Riverside Sunderland into one of the UK's most sustainable cities. Terry Fairfield, Technical Specification Manager at SIG, will be using Summer Lakes at the Cotswold Water Park in Gloucestershire as a case study to demonstrate the importance of rock face to roof traceability and show how early engagement with suppliers is fundamental to a project's technical performance, programme and price. And in the final presentation for Part 1, Nigel Osteen from Hawkins Brown is going to run through some of the guidance relating to MMC and designing for manufacturing and assembly, and use Plot N06 at the East Village in Stratford as a case study to explain the way the various categories of MMC impact on the design process. But before we start Part 1, we're delighted to be joined by housing expert Claire Benny, who's going to share with us some of the lessons learned from a career dedicated to improving the quality of the nation's housing stock. An architect turned client, her current focus is on raising standards within the public sector, but her insights on design quality, procurement and winning work are applicable across the board.
Good morning, everyone. My name's Claire Benny, and 5 years ago, having been both an architect and development director at Peabody, I founded a company to help public sector developers improve the quality of their new housing. Councils in particular are delivering more homes now. Some have completed hundreds of homes already, and others are only just gearing up, really. And what I do, first of all, is to tell those public sector clients that they've got huge power to direct quality. In fact, I think it's about 80% in their hands. And what makes me say that? Well, I think they've got 4 levers to get quality, which I've set out in detail in a client handbook for the GLA. And you can find this as a PDF online, and you just search for Delivering Quality Homes Handbook. So what do those clients have? Firstly, they've got culture and people at their disposal. In other words, they can lead quality from the top. They can set it out in a vision document, demand it from their consultants. They can visit exemplar buildings, employ people who are design trained, and reward quality when it's achieved. I wish that all happened more often. Secondly, good clients will write the brief and set the standards for projects. They set the budget for the scheme critically, and they can go further than regulation. They can set out detailed build requirements, and for instance, they can set out their attitude to the existing buildings on any given site and the trees. And it's a really powerful tool, brief making, which many don't use. And third, they can choose the designers and contractors who are best aligned to their quality goals. In other words, procurement. And I know this is a really tough topic for architects because public sector procurement can feel impenetrable and like a black box. But what I'd say is, I'm trying to support councils to be less driven by spreadsheets and to get to know the architect market better. I also mark design team bids on behalf of councils, and I can exclusively reveal that they're not very good. And if I had one tip for architects bidding for public sector work, it would be to listen more. Don't just talk about yourself. What is it that's on that particular council's mind? What would make you the right people for their challenges? And I can tell you that urban clients' main worry right now is compliance. So can you be both creative, which they do want, but also inspire confidence about meeting regulation too? And what's the final one? Well, council's final lever for quality is stewardship, i.e. the process of scrutinising and shepherding a project from concept to completion. And that means getting their in-house management teams engaged. It means keeping an eye on all value engineering that happens during a project, and it does happen, we all know it does. It means intense scrutiny during the pre and on-site stages, and it's possible to drop the quality ball as the client at so many points. But back at the beginning of this intro, I mentioned that clients were only 80% responsible for quality, and the other 20%, of course, is down to architects and contractors. There's some exemplary practice out there, like the design and construction of Goldsmith Street in Norwich, which got Passive House, and I know everybody knows that scheme. That involved huge commitment by the city council client, really detailed work by Michael Richards Architects, and the same attention to detail from R.G. Carter, who happened to be a local contractor. But all too often, that really dogged concentration on the quality prize isn't there from all three parties. And in particular, if there's one thing I'd implore architects and subcontractors to do, it's to take time out to learn the craft almost again of designing and building, and then making sure you do it to net zero. And the product manufacturers also have to join in here. We need a new generation of carbon neutral building products right now. And I'd characterize this as an industrial revolution. So enjoy Rethinking Resi and think in the background about what you can do for your public sector clients, which will both inspire and reassure them. Thank you.
Thanks, Claire. And now let's get started with part one, Modern Methods of Construction, with programme partner SIG. And I'm delighted to introduce our first speaker, Owen Phillips, Design Director at Legal & General Modular Homes.
Good morning, everyone. I'll be taking you through our approach to MMC construction here at Legal & General Modular Homes, and would first like to give you a bit of context around our vision as a business and what we see the purpose of MMC to be within specifically housing within the UK. As some of you may know, we operate out of a 550,000 square foot factory outside of Leeds, which is currently going through a ramp up in production towards an annual capacity of 3,500 homes a year. The purpose of this really is to build on our intent to disrupt how traditional housing is delivered, both in the affordable and private sale sectors, particularly aimed at first-time buyers, and providing fairness in housing throughout the UK. We're looking to do this through delivering at scale. I think it's important to highlight that there are a number of different ways to deliver MMC housing into the marketplace at various levels of scale, and the volume at which we're targeting has really influenced how we've approached our step into the marketplace. Building really on ensuring we deliver quality housing to both our client and the end user, that offers a high quality living environment, both within the home and also the setting in which the home is delivered, to the communities that we create as we deliver into the market. We do this through a fully integrated delivery, having influence and stakeholder engagement right from planning all the way through the process, through design, production, construction on site, and then into sales and aftercare, ensuring that our customers have a great experience with us from the minute they engage with us through into occupying and living in their homes. We do this through a mixture of in-house capability and partnering with third parties at pretty much all stages of this process, but really focusing on delivering high quality design, both in terms of product, place and process, to allow us to deliver on our commitments as we walk through the life cycle of a project. Just to give you an overview of the products that we're developing, they're all underpinned by 6 sort of key themes of comfort really, and ensuring that an end user values the space in which they live and call their home. So we start here with space standards, ensuring we achieve nationally described space standards across our products, providing high levels of acoustic performance and thermal comfort in excess of building regulations and minimum requirements, really looking to up the bar in what the consumer can achieve and expect to receive from their home as they occupy it. And that moves into indoor air quality and daylighting, again ensuring high levels of comfort and operation within the homes as people use them. We achieve EPCA as standard, so moving that benchmark forwards through a fabric first approach, removal of gas and use of technology in terms of heat pumps for heating and hot water. We've already achieved that as a minimum baseline and can offer then net zero carbon as we move forwards towards a more sustainable future as an industry, we hope. The images on the screen at the moment actually are 50-50 CGI and real life, and I'm particularly proud of the internal images there where I think you'd struggle to tell the difference between the two. So on the left hand side we've got an apartment product and a single family home, so our two core product ranges, which I'll talk you through as we go through the presentation, and on the right the internal level of finish that can be achieved within the range we produce. This is primarily driven by how we produce and the controls that we can achieve within the factory. So using a repeatable process and a systemized approach, we can ensure a high level of quality as we deliver, and just raising that benchmark and minimum baseline that a homeowner can expect to achieve from a newly built home. In case you were wondering, the image on the top right is the photograph from inside one of our single family homes. That's a 3-bedroom home with a large open kitchen dining space. And the image below is the CGI, which is the open plan space we've created within our apartment product, which I'll show you the layouts of later as we go through the presentation. The key thing that underpins our product design really then sort of sits beneath our ability to deliver at scale. So the modular industry always has that challenge of a factory that wants to produce one thing repeatably, the same thing over and over again to drive maximum efficiency. The real world obviously can't accept that from a requirement for different levels of performance, different levels of different context, different requirements for different people in different places. So the challenge we have as a business as we scale up, and I think as the industry looks to address the housing shortage within the UK, is how can we capitalise on MMC to deliver at scale, but resolve that conflict between absolute standardisation and ultimately maximum choice at a site and customer level. The approach we've taken to that is to go down a design route of components that then come together to form the dwellings that we deliver, and then ultimately the communities that we create. So what you can see on the screen here is a diagrammatic representation of a cut through of our apartment building, and actually focusing on the elements that aren't the apartments themselves. So the apartments are modules in their own right, and we'll come on to looking at the layouts as to how they come together later on in the presentation. We're really highlighting here that right down to the elements that connect all the components together, we've gone down an approach of building a library of parts and then using those to build different configurations and variances as we go. This helps us really to control our production process. So the images on the screen there are of our factory in Sherburn outside of Leeds. The image at the top of the screen is our housing line, so delivering out of cross-laminated timber 2- and 3-bedroom 2-storey homes. And the image on the bottom is the flow line that we've installed for our light gauge steel walls that go into our apartment product. We're able to get the throughput through our factory production line by limiting the amount of components we send into the factory. So working on that standard kit of parts. But then we put them together in a ways that delivers different outputs. And what we have to negotiate here is the difference between customization and configuration. So the difference between defined choice and absolute choice, because we have to maintain a throughput through the factory, but also meet the customer requirements at the end of the journey. This then starts to flow into site because the factory is only part of the puzzle really. The job isn't done when the module is complete. The modules have to come together, be constructed into buildings and finished from foundations through the install, into the facade and tie up into the roof, and then the external works that creates the development. And we take a similar approach to our sites. So that standard library of detailing, of interfaces, standard elements of work and standard processes that we roll out between all of our sites to ensure we deliver consistently. It also means we get lessons learned back from each of our sites, particularly as the factory has a standard set of labour who do a repeatable task day in, day out, and a site will have a different set of labour depending on its geography and the contractors we have involved. So actually we get a lot of breadth of ideas and learning from sites that we get in a different way to the factory itself. The key thing as we go through is ensuring we build quality in from the beginning. MMC resequences construction. It does things in a different order to the way the industry has been used to doing it for so many years. And therefore we get different challenges, how we protect elements of the construction, how we interface elements of the construction, access to points that if you were to build these buildings in a traditional way would be clear, but because we're in a modular format has obstruction. How do we get safe access repeatedly into the elements as we build? And we have to control this as we go through each step, because the thing you need at step 7 or 8 of the process may actually be fixed and formed earlier in the process. So we spend as much time focusing on how we build our houses as to what we build them with and what they become at the end. And the three pieces all interlock really to form a total solution. So what you see on the screen there is really a visualization of our build process, starting from sub-assembly, taking as much complexity out of the online build and doing that in areas away from the line to allow us to purely drive assembly in a flow production route through the factory. We then have stage by station set work repeatedly done. So regardless of which module we're building, they each reach the same level of maturity at the same point in the process. And then at the base of the image there, the magnifying glasses is the quality checks that go into place. So this is really defining what we term as critical to quality, borrowing techniques from automotive and aerospace, where we look at critical failure modes, what could go wrong, and therefore what controls do we have to put in place so that we drive the right level of efficiency into the process. So how the factory then takes the design, puts a construction process together, and then controls it is really key to us going back to the beginning of this presentation, hitting the volumes we need to achieve, but hitting them in a repeatable way that consistently delivers quality to the end user. Because after all, this is about delivering fairness in the housing market and allowing people to up their expectation of what they should receive with a new build home. We take the same approach on site, and traditional construction follows a similar process. We are engaged with the NHBC from a warranty provision point of view, so have formed our site processes in conjunction with their sign-off processes. And again, the graphic on the screen really visualises how that comes together. Again, control points at the right point in time to ensure that we don't carry a fault forward from one stage to the other. We avoid remedial works and rework from that perspective. I think it'd be useful to then give you some context as to what does this look like in practice, and what does this look like as we build into a community. Because again, we've gone from the small parts of the construction into the modules that come out of the factory, into the dwellings that get put together on site. But they only work as a scheme when we can put them together into a community with a sense of place, with a sense of purpose, and with a sense of community being built into what we deliver. So I'd just like to show you our site in Bristol, which is in Bonington Walk, just north of the city centre. We are delivering 185 homes. And that takes around about 560 modules for that delivery. We are delivering a mixture of all of our product types. So you can see in the image there some houses in the background and an apartment building on the front left of the image. So 2 and 3 bedroom homes, 1 and 2 bedroom apartments. The site itself was a piece of brownfield land located next to existing residential usage. There's a railway line to the south of the site, and areas of ecological interest within the large areas of trees, and also some protected species in there that we've relocated as part of this project. And you can see from the layout, we're creating a space here that not only creates a place to live in your own home, but creates space around the dwellings to live in. So high focus on cycleways, pedestrian access, as well as the use of the car, creation of green spaces and spaces with different settings and different contexts to allow different usage as people go about their day-to-day lives. And this is the intent as to what this will look and feel like as we work through the development. So real focus on how the public realm works in terms of hierarchy of transportation, use of green spaces and how the green spaces tie into the hard landscaping, and how we create a sense of character within what, to be honest, could be quite a stark, long street, but using features to break that up and create a sense of place and character. And you can sort of really see this in this layout where we can highlight the areas where there is density in terms of dwellings, where we have areas of green space that tie into the existing usage of the site and make great use of the natural features that were already there. How we've segregated cycle and pedestrian routes through the sites to ensure it's easily accessible for all users. And creating different spaces with different purposes. So capitalising on the existing community orchard within the bottom section of the image there by allowing the provision of new allotment space and tying in with what was there already, creating community squares and gardens within the landscaping and breaking the landscaping up into different areas of different character. And then also creating an area within the landscaping for the protection of the existing ecology that has been, some of which has been relocated as part of the works. And then from the 3D cut through here, you can start to get a feel as to how the site comes together with the provision of public open space, clear usage of the main thoroughfares for access, and then private space to the rear of the dwellings. And again, from the other side, really demonstrating the extent of open space within the development itself, offering people not just a place to live, but a community and a development with options as to how you live your life. So we've talked a lot about the development and the product itself as a house type, but actually we think modular then extends to all elements of the build. We're currently delivering the houses in a modular way, but how do we transfer MMC kit of parts approaches into elements of the build that aren't the primary house itself? And I think a really good example of this that fits into not just the character of the development, but also how people live and our strong drive for sustainable development is actually how we've dealt with a specific area of the product, a specific component to deal with waste and recycling. So we've taken now the kit of parts approach down to a level beneath that macro level of dwelling and into actually, for want of a better term, bolt-ons. What can we apply in addition to the standard product that creates functional, usable, but also repeatable elements of the design? So what we're looking at here is a modular bolt-on. It is a waste and recycling store designed to promote recycling, work with the local authorities' plans as to how recycling is dealt with, but also, as you can see from the image that we go to here, integrate them into the aesthetic of the development. This isn't just a bin plonked in front of your house. This is a considered element of the kit of parts that is functional and works with the aesthetic of the development itself. And that then goes into the apartments themselves as well, and I'll touch on this later as we go through the build-up of the apartment and how we have bolt-ons to the core, so to speak, of the building that allow us to create variants both in the facade, the fenestration, and elements that are applied to the external elevation of the building. So just to give you a walk through our products, these are the products that are being delivered in Bristol. So we have a 2-bedroom home. These generally are semi-detached or terraced, M42 compliant to NDSS standards. And you can see there from the layouts, spacious with clear provision for storage, and a functional layout that works with how people live within their homes. Again, exceeding very slightly NDSS standards. I'm looking for elements that give an increased look and feel and feeling of comfort while you're within the building. So you'll see in the image on the top left, full height windows to the upper floors. And this is a really good example of us marrying together the construction process with adding value to the customer. So that window actually came about through integrating the design of the product with the design of how it is built. That's obviously a first floor module, and as we go down the line, we need access into the module to complete the works. So we had a full height opening in the module as a necessity of process. We could have filled that back in and put a normal window with a sill in, normal whatever that means in design context. But we chose actually to use the hole that was created by the process to then give us an enhanced design feature in terms of the full height glazing, which then gives a light and airy feeling in those upper floor rooms. That then continues into the 3-bed, and you'll notice there's what is quite a solid, thick dividing line running top to bottom on those layouts. That's actually where 2 modules meet per floor. So our previous 2-bed house is 1 module on top of the other. This is 2 on top of 2. Again, this then works the other way. This is process constraint driving the design. So the width of this dwelling as a single unit would be prohibitive in terms of transportation, access, and limiting our ability to get to sites. So there is a practical aspect here of breaking this elevation down into building blocks that are repeatably deliverable across a wide cross-section of the country without constraining development opportunities at a land-led level. And again, you see a common theme here with the text at the top of the slides as to looking at comfort around space, open plan living, height, air quality, comfort, and making sure that people want to live in these houses. I think as MMC becomes more prominent and has done over the last few years, we're really challenging the sort of the preconceptions around modular housing. And I think flashing back to the images I had at the beginning of the presentation, where you really can't tell the difference between the photograph of the show home and the CGI that was created in the process. It's that real commitment to quality that just doesn't mean that MMC is a faster but lower quality product. Actually, MMC can be a more repeatably delivered higher quality product as a result of the processes that we use. And then the apartments really then demonstrates the next level of the kit of parts coming together. So again, similar themes throughout in terms of space, height, openness. But really here I want to talk about how the layouts between the 1-bedroom apartment on the left-hand side and the 2-bedroom apartment on the right-hand side allow us to use that standard kit of parts to develop quite a bit of variance. So you'll notice as you go down, the single bedroom with the sort of the family bathroom off of the main living space is the same between the two, as is the module underneath it with the utility cupboard and half of the open plan living space. You then get down to the third module with the kitchen and the dining space in. The only real difference between the 1 bedroom and the 2 bedroom is the door and the service connection then into the ensuite, which is the 4th module. So with 4 modules and the 3rd module having a minor variance, we can create 2 completely different properties, i.e. the 1 bed and the 2 bed. We then have a configuration where the 2 bed can come with or without the ensuite. And this is where we're driving configuration over customization. What are the allowable choices that allow us to get to a variety at a site level, but standardization in the build process? And where do those choices add value to the customer, be that a building owner and operator or an end user of the dwelling itself? The scale above the apartments then is looking at the layout of the building. So the layout of the building on the left is one of the 4 that are being delivered at Bristol. You will see on the left-hand side of that corridor, there are 2 2-bedroom apartments, and on the right-hand side, there is a 2-bed and a 1-bed. This is a ground floor plan, so there's obviously a lot of common space in there with refuse stores, plant room and cycle storage as well. As we go up the building, those areas are obviously not replicated, at which point they've been designed within a modular geometry so that we can increase the number of apartments at the upper level. So at the cross section above that, the 4 modules on the right hand side that have common areas of the building contain another 2-bedroom apartment at the upper floors. So that attention to detail in terms of geometry of grid and repeatability of grid is really important in us getting that standard component to stack and tessellate as we go up the building. That then corresponds into the base study of the elevation. So the balconies are in multiples of module width to interface at defined points within the columns. And all columns within the modules have all the connection points already built in, whether they're used or not. Again, similar to automotive, if you buy a car, the hardware for your car is probably all there, but the option packs that you pay for is turning it on or off. Similar principle in repeatedly providing the option to connect these elements to it, but choosing at a site level whether we do or don't make the provision for those elements. And then again, looking at creating place and sense of identity by playing around and having some fun with the facade, really. The element we've got here is masonry, using different textures and coursing and shadow gaps and rebates to create interest in the elevation in what could, from that repeatable geometry, be quite a stark and bland elevation, but using simple and effective, to be honest, tried and tested details to build character into these buildings and really debunk that myth that all modular looks the same. And I'd like to just really sort of end on firstly this image of the intent of what Bristol will look like for this shot taken from the public space looking towards some of the single family dwellings, and then comparing that to where we are now. So you'll have to forgive the dreary, grey, gloomy sky, as this is a week-old photo from Bristol, and the weather wasn't particularly great at the time. But this is looking from a similar part in that green space down the main avenue on the site. So the modules on the left-hand side are the houses, and you can see we've started in the distance, and the first modules to land, the last ones in the image, are already skinned with the facade and the roof is in place. And we're working our way through leading foundation plots ready for the modules to land, to be zipped up, to be made weather tight, to then be elevated and the roof go into place.
The image on the right hand side of the image is the foundations and cores for the 4 apartment blocks. You can just about make the 4th one out on the bottom right hand corner. And the one in the distance has got the ground floor modules in place. So we're working our way through the construction of those today. Typically, we're seeing an order of magnitude of 25 to 30% saving on construction time versus getting to a similar point in a traditional programme. And as is in the nature of a manufacturing business with aspiration, we are looking for opportunities to continuously improve that. But really, this all comes back to where I started, which is being a disruptor in the housing market and always consistently thinking about the customer's journey throughout, and actually life built in, not just technology built in or sustainability built in or whatever that might be. Life in its entirety is more than just the building blocks. It's how they are placed, how they are used, and what they mean to the people who live in them. Thank you for your time.
Thank you, Owen. You mentioned at the start of your presentation that while you have an in-house design team, you're also set up to work with third parties. Can you tell us a little bit more about how you work with external architects and urban designers and how this impacts on design and delivery?
Yes, certainly. I think just for some context, the internal design team goes across architecture, engineering and delivery, both the product development and placemaking. And we sort of firmly believe that when driving innovation, actually variety and difference in thought is really important to making sure we're generating the right solutions and properly critiquing the solutions that are put forward for an individual product or an individual place. So we operate either using key collaborators in a peer review capacity, giving us constructive challenge on the design solutions we're putting forward, or in reversal of role, actually, where we behave almost more like a technical client, relying on our collaborators to provide high quality design solutions to a brief that we then set and manage. I think the flexibility in how we do that is really dependent on the project itself, working closely with either area specialists when we're talking about product design, or when we're talking about place, actually local context and knowledge of local areas becomes particularly important.
Thank you. There will be an opportunity for you to put your questions to Owen at the end of part one, but now I'd like to introduce our next speaker, Connie Yachinska, who's a director at Procter & Matthews.
Okay, good morning, everyone. First of all, I'd like to thank you very much for inviting me to speak at this conference. I'm going to talk today about one of our current projects where we're using different types of prefabricated panelized construction systems, and where we're learning quite a lot about the opportunities, but also the challenges of this form of construction. The project is called Walks Living, and it forms part of the wider Riverside Sunderland Master Plan, which was commissioned by Sunderland City Council and their development partner Igloo Regeneration, and forms part of the wider ambitions of Sunderland to revitalise and regenerate the city centre. We've been working on the master plan together with Faulkner Brown and Mawson Kerr Architects. And the overall master plan delivers around 1,000 new homes across 5 neighbourhoods, alongside up to 10,000 workplaces, green infrastructure, social infrastructure and community facilities. The Vaux neighbourhood itself sits right at the centre of the master plan on the old former Vaux brewery site. The landscape in this location is really quite dramatic. The sides of the river Wear form really steep, tall cliff edges. And the general design concept, both for the master plan and for Walks Living, have been based on the industrial heritage of Sunderland, and in particular on the historic skyline. So on the images to the left, you can see the old industrial building sitting on top of the cliff edge. It was mainly tile manufacturing and glass manufacturing, and they form this distinctive skyline, which we've tried to reproduce with modern typologies. This is an early concept sketch, which again shows the neighbourhood sitting on top of the cliff edge, which offers fantastic views across the river and across the wider landscape. The Vaux neighbourhood itself forms part of Sunderland's Future Living Expo, which is going to happen in 2023, and which showcases sustainable modern forms of living as part of the wider Sunderland regeneration. The neighbourhood offers 132 dwellings, 41 of which are apartments, and they're all arranged in smaller clusters. We're working on the project together with Morse & Co architects, and each architectural practice is designing one of the apartment buildings, which is shown here in red, and then some of the terraced housing and maisonette within the clusters. The project is currently between stages 4 and 5, but I'm going to be talking about procurement in more detail later. There's quite a wide range of typologies on the site in line with the ambitions of the Sunderland Expo. And they're all based on historic weir-side typologies. So the apartment buildings have been inspired by traditional peel houses. You can see in the picture on the left. Then there's the Sunderland cottage, which we've used to develop our terraced house typologies. And then there's the weir-side maisonette, which has inspired our maisonette units at the end of each cluster. In terms of overall design aspirations, we're trying to create a modern, sustainable neighbourhood where people can live an active and healthy lifestyle in a high-quality designed neighbourhood. The materiality is based on, again, the historic materials of Sunderland and of the site. So we've been looking at the tiles and the glass that used to be manufactured there and traditional colours and materials. And so there's a brick base that unifies all the buildings at ground floor level and ties everything together. And then on the upper levels, there's a mix of clay tile cladding in different colours and different sizes that gives variety to the elevation. Like all igloo regeneration projects, there's a very holistic design approach based on igloo's footprint methodology that looks at the overall impact of the development on its environment. So we're looking at aspects like climate, circularity, the connection with nature, but also community, sense of place and well-being for the residents who are going to live in this neighbourhood. The sustainability strategy forms a very important part of this, and the development employs a huge range of smart technologies. We've been looking into sustainable materials, locally sourced materials, and there's a whole life cycle assessment that's been done for the development. The external fabric of the buildings has got really high performance. We're going for a U value of 0.15, and one of the buildings is going to be Passive House certified, while the ambition is to employ the same Passive House standards for all the other buildings, including air tightness levels of 0.6. It's also a car-free development, so there, apart from a few disabled bays, there's no parking within the neighbourhood, and all the parking will be happening in parking barns that can be reached within a few minutes by foot in an adjacent neighbourhood. Another important part of the brief was modern methods of construction, and from the very beginning we've been talking about and looking into different types of MMC and fairly quickly settled on panelized construction methods, just because they give us more design flexibility than, for example, a volumetric approach. So the apartment blocks that are shown in red here and that we call the peel houses will be constructed from a load-bearing light gauge steel frame system, whereas all the houses and maisonettes will be built in either a SIPS or timber frame system. Both the light gauge steel frame system and the timber frame system have got similar advantages in terms of ease of construction, logistics, construction speed, but also they're very accurate because they're being produced in a factory under factory conditions. There's less dependence on weather and on site conditions. There's less construction waste, both on site and in the factory, and they're made from recyclable and recycled materials. And also they give us pretty much the same design flexibility that we would have had with a traditional system. So they're both really good systems to work with. I think in order to get the full benefits out of panelized construction, there's really two things to bear in mind. One is the program, because there is quite long lead-in times, so all the designs have to be finished quite early on. And the other thing is the involvement of the manufacturer in choosing the point in time when the team starts working with the actual manufacturer of the system. And in our experience, the earlier this happens, the better, because these are highly developed systems and the manufacturers really know what they're doing and can really help with putting together the building and developing the details. And the later they come on board, the more complications you might have later on. And this is true both for the light gauge steel frame and for the timber frame as well. Possibly even more for the timber frame, because there is more variety in the market when it comes to timber frame or systems. Which leads me on to procurement. This is a design and build project which was procured as a two-stage tender with a pre-contract service agreement, PCSA. And it was tendered on a fairly robust and fairly well-detailed set of information, because as architects, we believe that it's really necessary to resolve quite a lot of the details at tender stage to be able to get the best value out of the contractor and the best design quality later on. So the idea of this PCSA period is that during the time, which in this case sort of lasts 3 to 4 months, the contractor will work very closely with both the client and the design team to firm up the design, to further develop the details, and to start working with specific contractors and subcontractors, if they're not already on board, to firm up the price and to be able to then give, at the end of the period, the client a much more accurate cost of the project. So in this instance, we started working with the contractor, but they were really struggling, especially with finding a supplier for the timber frame. It was agreed at tender stage. We had a lot of discussions whether to already approach a particular manufacturer at stage 4 when we were drawing up the tender pack, to be able to work together with them and develop much more meaningful details. But it was decided in the end to not do this and to draw the framing systems in a quite generic way in order to keep the options open and allow the contractor to go to the wider market. But it meant that once we came to the PCSA period, the contractor started looking into the timber frame a bit more and realized that it was quite difficult to find someone who would be able to satisfy all the brief requirements, which were quite onerous. And whereas light gauge steel frame systems are quite similar in terms of what's available on the market, there's a lot of different SIP systems and timber frame systems. There's open timber frames that arrive on site without the insulation, and then the contractor will fill in the insulation and close them up. Or there's fully integrated SIP panels, which come fully insulated, sometimes have windows in them already. And then there's difference is in how the structure works. Sometimes they're fully structurally supported in themselves. Sometimes they need additional timber elements to help with the racking. And they all achieve slightly different U values, slightly different air tightnesses, and have different levels of certification. Now, for this project, it was really important that everything is NHBC certified and approved. And there's actually not that many systems on the market that can do this. And I think the other main issue was the air tightness that we were trying to achieve. Because with the timber frame, it's really difficult to achieve 0.6 just with the timber frame alone. It always relies on work on site. So in the end, after a lot of research and after a lot of meetings, we realized we had to drop this requirement and go with a more standard level of air tightness. Unfortunately, the architectural team wasn't involved in all the meetings at this point, which I think made it more difficult as well for the contractor to find a good system, because there was a lot of misunderstanding of what the system was trying to do and what the design aspirations were. So in hindsight, I think if we had been involved a lot more, if we had been able to approach a manufacturer at a much earlier point in time, it would have been much easier. So as a result of this, at the end of the PCSA period, we still really didn't have a timber frame manufacturer, and also the cost of the project had increased by nearly 50%, which was also to do with Brexit and COVID and the volatility of the market at the moment. So we went through a fairly extensive VE exercise to reduce the cost, and it was decided to extend the PCSA period by another 4 to 5 months, during which we would then be able to work together with steel frame and timber frame subcontractors to develop the buildings a bit further. So the two biggest changes that we made to the design was we simplified some of the geometry to make it easier for, in particular, the timber frame to be constructed on site. And we replaced the clay tile cladding on the upper levels of the building with brickwork, which works really well from a design point of view, but threw up more problems when it came to the timber frame construction, because the timber frame, while it can carry lightweight cladding, it cannot support brickwork where it doesn't go all the way down to the ground. So, for example, on site return elevations where the wall doesn't go down to the ground, we then had to look at different types of lightweight cladding. And every timber frame manufacturer has got different test certificates for different types of cladding. So they can only put cladding on their houses that has been fully tested and certified. And the manufacturer we're working with at the moment, which is Donaldson Timber Systems, formerly known as Stuart Milne, they've got an amazing system, but they only have certification for 2 types of cladding, both of which are very limited. Which is not only necessarily to do with the cost of the cladding tests, which are very expensive, but also the availability of the test rigs. At the moment, everyone wants to test their cladding for fire, so you have to book in these tests months in advance, which is time we don't have. So we're working on that at the moment to try and find a material that we can safely use, that is NHBC certified and also satisfies the planners and works with our project. So these are sort of the main hurdles we had to overcome. But we're now working with the manufacturers, and it's brilliant because they really know what they're doing. They're helping us detail the buildings, and it's a really nice way of working because we can now finally resolve all the issues we had. We have got a closed, fully integrated timber frame system where the panels arrive fully insulated on site. They're closed in. They just need to be lifted into place and then clad from the outside. In terms of the light gauge steel frame, it was a lot more straightforward because the systems available on the market are fairly comparable. The main obstacles we had with this are less to do with the steel frame, but more to do with, I think, the times we live in, due to the non-combustibility of the insulation, and which makes the insulation really chunky, and the slenderness of the steel frame, which is only 100 mil thick. We end up with a lot of external insulation and really thick walls, which from an architectural point of view is great because it gives us great big reveals. And also takes us back to the times of the old peel houses that did have really thick walls already. But from a technical point of view, it creates issues because it makes the cavity so wide that it's really hard to find cladding brackets that span all the way, fire breaks. All the things that bridge the cavity are just becoming really big for a 600 millimeter wide wall. So to summarize, we're really excited to be working with panelized prefabricated systems. It's really made it easy in a way for us to design the project, especially now that we're working together with the manufacturers. These systems are ever improving, they're getting better all the time. So we're very excited about carrying on working on this project and about the future and seeing what else is going to happen in the prefabricated panelized world. Thank you very much.
Thank you, Connie, for giving us a fantastically candid account of the trial and error involved really in any innovative project. One key message is that in order to get the full advantages of working with panelised construction, it's absolutely essential to engage with the supplier as early in the design process as you possibly can. But as you've demonstrated, identifying that supplier is by no means straightforward. What advice could you give to other people who might be facing the same sorts of issues? So is there, for example, a website or an organisation that can give an overview of the various systems on the market and maybe help an architect or a contractor or developer to make an informed choice?
I think there's a series of really good websites out there that talk about panelised construction in general, but I'm not aware of one that provides a really detailed comparison of all the systems that are available on the market, which is maybe partially to do with the fact that the market, especially when it comes to SIPs and timber frame, has been evolving really rapidly over the last few years, and the systems are improving all the time. So I think our advice would be to just start doing research really early on and be very clear about what you need the system to achieve, especially if the project has got quite ambitious performance targets like we had on Vaux. And there's a lot of really brilliant systems out there. They're just all slightly different. So it's really about finding the one that delivers the solution that is right for that particular project.
Okay, thank you. Now, Connie will be joining us for the Q&A session at the end of part 1, so please do send through any questions you might have. But now I'd like to introduce our next speaker, Terry Fairfield, Specification Manager for SIG Natural Slate.
Thank you very much for joining me. Today I'm going to be discussing a project that's focusing on the selection criteria for the materials, and then also looking into some of the technical aspects regarding this project and the aesthetics, etc. This is a project at the Summer Lakes development at the Cotswold Water Park at Cirencester in Gloucestershire. And as you can probably see from the photographs, these are old sand and gravel pits that have been converted for use for various reasons, like business, sport and leisure, and residential, as per this project that you can see. We've been supplying materials onto this project now for several years. It's very much, it's a project that's build as you go. So we started this beyond 5 years ago. And one of the key focuses with the project is that it's the continuity of supply of materials. And as I'm sure many of us are aware, over the last couple of years, that's been particularly important, particularly with the importing of materials from other parts of the EU, for example. So with regards to the slate selection, this is our SIG slate, a 13S. And we bring this in from the northwestern part of Spain, where the majority of natural roofing slates is produced for the world. I think something like 90% of natural slates in Europe are all supplied from this small region in Spain. And as you can see from the photographs there, this particular slate is from an open quarry, where slate is the top layer of the material is taken away, and then the quarry digs down into these large blocks of slate, which then are ultimately cut down to size, and then still, as per the majority of natural slates that are produced, whether in Spain or in Wales or Cumbria, for example, they are still hand split. So to bring it down to that last few millimeters, there is still people at the end of the factory line with bolsters and big hammers to split them down. The benefit of that is you do get this lovely material, which gives you a nice textured appearance. This region is from the Labanya region, and with that particular quarry, we do get a nice grain with a top to bottom line starting to appear, which is a very traditional sort of finish. It's also a quarry that we've worked with for many, many years, so we are very well aware that the availability and the continuity of this material is going to be good. So when we were discussing with the contractor on the site the long-term supply, we were able to assure them that this quarry has still many decades of material available, and the volumes that come from this quarry are going to be good, and we're going to be able to satisfy what they require for this site. Now, I think if there's early engagement with suppliers, very often this sort of thing can be a real advantage, because if we're aware of a project like this, we can then steer the product selection towards the correct quarry to try and prevent any issues occurring further down the line. Once the quarry has been selected, we are then able to work with our local branch network and make sure that we have a decent supply of materials to act as a buffer to sit on the ground so that we're able to supply fairly quickly as and when required. The delivery period from the quarry face into the UK is probably about 3 weeks or so. That does vary depending on what's happening with shipping and with vehicle transportation and so on. However, generally you're looking 3 to 4 weeks for products from Spain. Products from other parts of the world can range anything from 6 weeks to 12 weeks or something like that. One of the key things to take into account when selecting a natural slate also is the testing and accreditation. Now, the British standard for natural slate, which is BS 12326, is a very technical document. There's lots of details about the variation in sizes, the variation in flatness and so on. But the 3 key details that specifiers need to be aware of are the testing accreditations that you can see on the screen. So we have the W1 test, which is the frost resistance. So the slates are tested for their water absorption. The thermal cycle, you do sometimes get inclusions in natural slates. Often the gold ones are known as fool's gold, but they're pyrites. And they are tested, wetting and drying process is carried out to see whether or not they will cause discoloration on the slate surface. And then sulfur dioxide testing, which is like an acid rain test, just to see how the material will last over a certain period of years if it's in a city that has high levels of pollution. Generally, and it's very much a generalization, Spanish slate scores very highly on all of these materials. The only one to be aware of is the thermal cycle. There are some T2 products available on the market at the very budget end of the price range. As always with these things, if the price seems it too good to be true, then the chances are it probably is. So that's just the one to be aware of. All slates then do need to have a declaration of performance, and these details that you can see on the screen where we're showing the test results, they are also printed out in a smaller format, and every crate of slate that comes into the UK from Spain or from Brazil, for example, will have that documentation attached to the crates. So going back to the project at the Cotswold Water Park, one of the design features on this roof is that the main roof is at a standard sort of pitch. So at the higher level, we're looking at 30 degrees plus, and at the lower level, we're looking down towards 22.5 or 25 degrees for a wraparound area on a lower level. Now, as you can see from the the picture and the chart on screen, these details will vary depending on which part of the UK your project is based. Now, as you can see, the Cotswolds are in the sort of bluey grey area down in the southwest, and that means we require a higher level of headlap and batten gauge for the product, and also the sizing will be slightly different. In the western part of the UK, the minimum pitch requirement for a 500 by 250 slate is 30 degrees with just under 100 millimetre headlap. Now, once you go below that pitch, you need to start looking at a wider slate, a 500 by 300, which can bring that down all the way to 22.5 degree at a 130 millimetre headlap. Now, in the eastern side of the country, which I'm not showing at the moment because it's not relevant to the project, there's about a 5 degree difference. So you can have a 500 by 250 millimetre slate that will come all the way down to 25 degrees and slightly lower pitch on the larger slate as well. But with the wider slate, what you do is you're actually moving the nail holes slightly wider than a 500 by 250. And that means as the water starts to track under the slates and move sideways, it's got an extra few millimetres on each side to keep it weather tight and protect it from any water ingress. So we were lucky enough on this project that we were able to provide both a 500 by 250 and a 500 by 300 slate that we could take down to 22.5 degrees as required for the lower pitched roof. All these details that you can see in front of us are all taken directly from the British Standard for Slating and Tiling, which is BS 5534. If you wish to go below these pitches, there are products on the market. There's one or two systems out there which effectively take that weatherproofing away from the slate. So sometimes it's a neoprene strip that will go up in between the slates itself. Sometimes you get specialist underlays to go underneath that. But again, both of them are taking that weatherproofing warranty away from the slate and onto their own product. So just to summarise, it's very important to get involved early with regards to the product pipeline and making sure that the product that you're selecting has enough volume and has enough material running through a period of time to keep your site supplied and have enough of what you need on the ground as it's required. It's also best to speak to somebody regarding the fixing specification. Different parts of the country require different size slates sometimes and require different headlaps and gauges. And obviously, if that can be arranged early on in the process, then when the project goes out to tender, then all the roofing contractors and subcontractors will be pricing for the same specification. And that makes it a lot easier, so there's no surprises further down the line. As I've said previously, we can help with the selection of the quarry so that you can have the right product for the right project. As I said, if you've got a project that's running over several years, we can steer you towards the bigger quarries that are supplying large volumes of materials, and we know they have a good lifespan within them. If it's a one-off project, if you're doing a one-off house, for example, again, you may have a bit more choice because we can look at what's on the ground immediately and then give you some variation into what you want to supply straight away. And one of the key things from our point of view is that rock face to roof traceability. Very often, once slates are taken out of their crates and out of their packaging, it's very, very difficult to identify what the product is. So once it's taken out of the crate, it's even somebody who's worked in the industry for a long time, it's very hard to identify what those slates are. If you involve people early on in the project, we can help you with all the paperwork and the accreditations that you require. So you've got full traceability from that quarry to the roof, and we can offer guarantees and warranties to go alongside that. I hope you found that useful. And as you can see from the photograph, it was a very nice project, which I think is just coming towards the end of its installation now. So thank you very much for your time, and I will pass you back.
Thanks, Terry. I'm interested that you have different recommendations about roof pitch and fixing specifications, depending on which part of the country you're building in. So to what extent do these recommendations take account of global warming and predicted changes in weather patterns? And as a related point, what level of future-proofing can you guarantee?
I think that's quite a difficult question, actually. We are, all of our specifications are based upon the British Standard requirements, which use the current wind loading calculations that I showed during the presentation. I think a lot of that hasn't changed for possibly, I think the last revision was 2014. So I would imagine that there's something due relatively soon because of obviously what we've seen with climate change and the storms we've had even this year recently. I think we are finding some architects and specifiers are asking us about this now and starting to mention future proofing. So we are able to do some basic things to try and upgrade specifications, you know, changing the calculations, moving the areas along slightly or the pitches slightly to give that additional reinforcement. So, but I would imagine that you're quite right. I think that the fixing specification element of the British Standard is due for an update relatively soon. Most manufacturers, I would suggest, are involved in the organisations to work alongside the British Standard. So watch this space, I would say.
Thank you for that. And you'll be able to put more questions to Terry in the Q&A panel discussion after the final presentation in part 1, which is by Nigel Osteen, who is a partner at Hawkins Brown.
Thanks, Isabel. Hello, everyone. So I'm going to be talking about modern methods of construction and designing for manufacture and assembly. I'm going to cover 5 things over the next 15 minutes. I'll give you a quick overview of the DFMA overlay to the RIBA Plan of Work, published about 6 months ago. Then I'm going to discuss the role of MMC advisor that we introduced with the overlay and the importance of early engagement with manufacturers and suppliers. Following that, I'm going to talk about the DFMA Toolkit, an app launched in December last year that helps housing providers adopt MMC. I will talk briefly about how measuring PMV, pre-manufactured value, is a helpful proxy for good outcomes. And finally, I'd like to show you a recently completed residential sector building designed by Hawkins Brown and constructed by Mace, which is shown here, and which uses innovative off-site systems and has achieved a high PMV, over 70%, without using MMC categories 1 or 2, that is structural, volumetric or panelized systems. And I think this is important, as most of the conversation around MMC, particularly in the residential sector, is CATs 1 and 2, but categories 3 and 5 are more straightforward to adopt, and decisions can be made later in the design process, which is, of course, helpful commercially. For those who aren't familiar with the MMC categories, this is them. Category 1, as I said, is 3D structural systems or volumetric pre-assembly. Category 2 is 2D flat pack structural systems. Category 3 is non-systemized structural systems, so things like precast concrete or cross-laminated timber. Category 4, I've put on the bottom line, as it's not really a thing here in the UK, but it's 3D printing. Category 5 is non-structural volumetrics like bathroom pods, but also M&E and facade assemblies. Category 6 is traditional products, but in large format for easy erection. And category 7 is process-led improvements like BIM, robotics, LiDAR, and so on. And it's categories 3 and 5 that my case study is going to focus on. Before I start, I just want to take the opportunity of introducing you to the Offsite Alliance, which Hawkins Brown is a founding member of. These are the sort of organisations that are members. There are very few architects at the moment, so we're really keen to get more. There are a series of strategic work streams going on, which are listed here, and I'm leading the design integration group that we set up with the aim of bringing designers and manufacturers closer and to improve collaboration. Within that group, we have a specific work stream we're just starting to develop practical guidance on designing category 1 volumetric, which we aim to publish later this year. So look out for that. The OA is a fairly new organisation, so if this sounds like the sort of thing you might be interested in, please drop me an email or message me on LinkedIn, or just go to the OA website where there are joining details. I'd particularly love to see more architects joining. So the DFMA overlay. The first edition was published in 2016 and based on the 2013 plan of work. We published the second edition last September, and it is, of course, based on the 2020, the current 2020 plan of work. Even though it was just 5 years since the previous version, a lot has changed in the world of offsite, and it was important that the new overlay and the report reflected that. For those who haven't seen the overlay, you will no doubt recognise the plan of work format with the 8 work stages from 0 through to 7. The overlay quite simply puts design for manufacture and assembly activities against each of these stages, as well as giving other guidance. And many practitioners and contractors use it to guide their workflow and project programming. The accompanying report gave us the opportunity to cover quite a lot of ground. So obviously, to explain for the uninitiated what DFMA is all about, to set out the MMC categories, which I outlined just now. So important, I think, to have a common vocabulary. We wanted, through case studies, to demonstrate that offsite need not curtail creativity, and in fact can be a driver for quality. And I think the case studies we put in the report demonstrate that pretty well. We wanted to emphasize the close ties with digital technology. We wanted to show how procurement need not be a barrier to MMC, and we wanted to look to the future to see what that might bring. In particular, we wanted to set out what designers and project teams need to do differently, and to provide practical advice on the early stage optioneering process, which is so critical to the success of a DFMA approach. In the report, we introduced the role of MMC advisor. We say that it's a role that can be carried out by the architect, where they have the necessary knowledge, or indeed the client if they do, or it could be a specialist. But it emphasized the need for different thinking, and that the opportunity for delivering value through MMC can be lost if decisions are made too late. So on that basis, we've developed this matrix showing when the different actors in the project team, including the MMC advisor, need to be brought in, and when design freeze needs to happen for each of the various MMC categories. The bars show when ideally that organization would start their involvement, and then the latest time is where the bar changes from blue to green, and then when they would finish is at the end of the bar. The pink line shows notional planning approval during RIBA stage 3, and the yellow when you need a design freeze, which varies for the different categories. A big point to note here is the need for collaboration. MMC really cannot happen if the design team and the manufacturers do not work closely together. So anyway, this is all available to download, and you can find it by just searching RIBA DFMA overlay. So next, I want to tell you about an exciting piece of software that we've developed as part of the Colab Consortium, a partnership between L&Q, who you will know as one of the largest housing associations, technology company Virtual Viewing, HTA Design, and Hawkins Brown. We set up the consortium in 2020, and we were awarded funding by Innovate UK under the Transforming UK Construction competition. And our proposal was to develop a digital solution to address some of the key issues facing the construction industry. The toolkit, which we launched in December last year, is going to enable house builders and their design teams to store digital portfolios of offsite manufactured products, including house types and flat types. It will enable them to source materials and also to capture data to inform decision making. We're hoping it will help overcome some of the barriers to MMC by encouraging housing associations to think about the building process early on. All too often, as you'll be aware, offsite is only considered once the design has been drawn up, and by this point the benefits often can't be realized, and it works out more expensive than traditional construction. It will also bring efficiency to the design process through the use of standardization. So it will act as a central portal that gives access to design information and 3D model information that can be used by project teams in developing their design, and allows them to select the products or components such as balconies, bathrooms, and indeed whole apartments from a set of standard products. We estimate that this toolkit could speed up design and construction programs by 30%, so it could offer significant improvements in productivity. The standardization that underpins the toolkit is based on L&Q's production innovation roadmap, which sets out their ambition to develop a portfolio of MMC products, systems, and procedures, and to allow to follow a product and portfolio way of thinking rather than looking at each project as a bespoke brief. By doing this, they will be looking to deliver more certainty on cost and quality, improve efficiency and productivity, and to deliver at scale whilst reducing risk. So if you'd like to take a look at it, just download it from Windows or the App Store. What we've developed here is a proof of concept, and it's It's now ready for organisations to develop their own digital assets and use the app or something like it as a platform to provide a single source of truth for their own portfolio of off-site products. I said I'd touch on pre-manufactured value, or PMV. This is an extract from the government's guidance published back in 2019, but although it was a while ago, I think it's still something many people aren't familiar with. For those who are, bear with me for a moment. Pre-manufactured value is the financial proportion of a construction project's gross construction cost derived through pre-manufacturing. Pre-manufacturing includes all costs incurred prior to the final installation of the construction work phase, including all materials, the total labour applied in the pre-manufacturing process is fixed and variable, manufacturing overheads and associated plant, logistics and transportation costs. By gross construction costs, we mean all pre-manufactured costs, on-site labour costs, all preliminaries, costs, overhead, profit and risk. And this slide shows how the different categories of MMC can improve efficiency. Hopefully you can just about make out the numbers of the categories on the arrows. And this slide gives more detail on how that's achieved. On the left-hand side for categories 1 to 5, and on the right for 6 and 7. So we're measuring PMV not just for the sake of it, but because it's a proxy measure of a range of benefits against a traditional approach. So PMV then is a percentage, effectively the off-site cost divided by the total cost. So just to conclude this, I'm going to talk about Hawkins Brown's recently completed project, plot N06 at East Village in Stratford, overlooking the Olympic Park, which utilises several category 3 and 5 modern methods of construction, and in some cases a combination of the two. It's a build to rent project for Get Living, providing 524 homes across 2 towers of 26 and 31 stories. You can see the towers are linked halfway up with a double height sky bridge, and this contains the main communal amenity space in addition to those that are on the roof. The project was delivered by Mace, who emerged as the preferred main contractor on the project early in RIBA stage 4. At that time, they were building an adjacent high-rise scheme using their jump factory system, but this had some limitations, and they were looking into the next iteration of high-rise construction based on a system being used in Australia called Hickory. So just to reiterate, within the government definition framework, category 3 encompasses many types of prefabricated primary structure and substructure, shifting away from reliance on in situ works as far as possible. This is the definition of the MMC framework. So it talks about use of pre-manufactured structural members made of framed or mass engineered timber, or hot or cold rolled steel, or precast concrete. And it includes load-bearing beams, columns, walls, core structures and slabs that are not substantially in situ constructed and not part of a systemized design. At East Village, almost all the superstructure was precast concrete, and from the floor slabs to the columns, the shear walls around the central core and the stair flights. Mace formed a partnership with a precast designer and a supply chain of manufacturers to produce each of these elements. It's not shown here, but stair flights were combined with steel balustrading pre-attached as a permanent guarding, which removed the need to erect temporary edge protection. MMC Category 5 covers non-structural assemblies and sub-assemblies, including walling systems and mini-volumetrics. This is the definition from the MMC framework. It talks about a series of different pre-manufacturing approaches that includes unitized non-structural walling systems, roofing finish cassettes or assemblies, non-load-bearing, mini-volumetric units used for things like kitchens, bathroom pods, utility cupboards, risers and so on, as well as preformed wiring looms and so on. At East Village, this included the aluminium unitized curtain wall facade with GRC attachments, bathroom and utility pods, 3-story riser modules, and many of the primary horizontal service runs up to each apartment. Obviously, there's a great opportunity for quality control using bathroom and utility cupboard pods, because the products can be inspected before leaving the factory. Additionally, we found that by limiting the number of pod types, we could really streamline the benchmarking and production process. And with a high degree of repetition, the future maintenance of these and other elements becomes much more efficient. And this is really important for Get Living as the operator of the buildings in the long term. Getting early engagement with the main contractor and input from their supply chain was really beneficial, and allowed us to reach a higher degree of resolution early on to support the off-site manufacturing lead times. Bathroom pods can be considered for almost any residential project, really, and are well suited to this sort of approach with their repetitive nature. The main considerations as a designer are to factor in enough tolerance for varying wall and floor build-ups between manufacturers, and to consider the sequence of installation so that access is allowed for final connections when the pod is shifted to its final location on the floor plate. However, the unique approach that was taken at East Village was the combination of the Category 3 floor slab with Category 5 facade as part of Mace's high-rise solution, which also factored in the mini volumetric elements. The unitized facade was pre-attached to floor slab units at a holding facility in Norfolk, then loaded onto the back of an articulated lorry and dispatched to site. Similarly, the horizontal service modules were pre-attached to the underside of the corridor slabs surrounding the cores. Once the delivery arrived on site, within its defined time slot, it would be attached to one of the 5 tower cranes and then lifted to its designated position. We estimate that producing these assemblies off-site, tracking each asset digitally and dispatching for just-in-time delivery has reduced vehicle movement by at least 40% over traditional builds, so significantly reducing environmental disruption and noise and pollution around the site, and reducing disruption to nearby existing residents and businesses. And once the construction process had gathered full momentum, Mace achieved a 5-day cycle with 1 floor being installed each week. They developed a sort of production line ethos with each interfacing trade understanding their timescales and responsibilities to be able to pass the baton on to the next one. The key advantage of this approach is that once the combined slab and facade units are in place, there is a complete envelope around the slab perimeter, almost eliminating the need for temporary edge protection and offering a safe working environment for operatives, which, of course, as you know, is an important factor when constructing tall buildings. There are also further environmental benefits, because site wastage was reduced by an estimated 75% over traditional build, with everything arriving pre-assembled or cut to size. Despite me saying we need to bring considerations of the method of construction earlier in the design process, this project wasn't actually designed at the outset with MMC in mind, but we did design it with a rational layout and a high level of repetition and stacking, which made using the Mace system relatively straightforward. The high-rise solution was superimposed onto an already developed floor layout, and only very minor tweaks had to be made to accommodate it. We didn't want the MMC approach to be overly apparent in the completed building. To ensure that the original design intent wasn't compromised, we had to think carefully about where the unitized curtain wall panels coincided with floor slab panels and how they joined together, so that any doubled up mullions were expressed as a feature or partially concealed by the GRC attachments. MMC is well suited to the build to rent sector, and using this approach that we have has significantly accelerated the construction program, literally shaving months off a traditional build. For our build to rent client and their investors, this was considered extremely attractive, as they could get tenants in and generate rental income much quicker. Thank you.
Thanks, Nigel. Can I just pick up on your call for architects to join the Offsite Alliance? Could you give an idea as to the type of practices you're looking for and what exactly you'd expect them to contribute, and crucially, what's in it for them?
Well, it's a fantastic organisation. It's relatively new. It only started charging fees this year, but it's already making a real impact. We've got a stage this week at UK Construction Week. I was there yesterday, and the sessions were absolutely packed. So we're getting really great conversations happening. I think for architects, it's an opportunity to get to know the contractors and the manufacturers in this area, and I'm really keen that we use it to influence the direction of offsite and to push the quality agenda in particular. So I'd love to have architects join and get involved, and maybe join one of the work streams that I mentioned. And it's a great opportunity to to make connections with like-minded people. It's a real opportunity to sort of learn and grow your network. So yeah, if people would be interested, have a look at the website or drop me a note on LinkedIn.
Okay, great. Thank you for that. I'm now going to ask Owen, Connie and Terry to join me for the panel discussion. And fielding the questions, we have my colleague, Jason Sayer. So Jason, what have you got for us?
We've had lots of questions coming in, so apologies in advance if I miss anyone out. The first one, though, is for everyone, and it's about timescales. So thinking about timescales, how does working with modern methods of construction compare with traditional methods? Has anyone recorded any data on this?
Okay, Nigel, I think I'm going to put that to you first, because I'm guessing you're going to know where the data is. So can you answer that for the audience, please?
Yeah, I don't know. I mean, data is really hard to come by in our industry, isn't it? I don't think we're particularly good at sharing it, and I'm not sure that there is a sort of particularly well considered set of data on that. I think the manufacturers will have figures, but I don't think it's across the whole industry. I think there'll be individual organisations will be able to say what speed of benefit and speed they're bringing. So I don't think there's anything across the industry. I think we should be measuring it and doing that. We need an organisation perhaps like the OA that could start doing it.
So Owen, can I actually put that to you as well? Because presumably those figures about the sort of difference in speed on site between modular construction and traditional construction, that's a huge part of your sales story and your business plan, isn't it? So do you have data that you're allowed to share, or is it commercially sensitive?
Yeah, broadly speaking, Nigel's right. I think the data is currently predominantly in the hands of the manufacturers. And I think it's also important to acknowledge that as soon as you take something off critical path, something else then becomes the critical path. So there's a lot of choices around specific sites that impact delivery. Obviously, in terms of our delivery method, we use our site savings to sort of leverage our delivery. Broadly speaking, we see around about a 30% reduction in on-site time compared to a traditionally delivered low-rise housing development. As a lot of our sites are more suburban with a mixture of houses and apartments. That will then be slightly different for something like a project that Nigel talked through, where it's predominantly high-rise and urban in that setting. So there's a lot of variables, but from our experience, that's broadly the order of magnitude.
Okay, thank you. So Jason, what other things are the audience keen to know from our panel?
Sure. So the examples shown show sites that are in general relatively easy to access, something that's actually highlighted by Owen in particular. But I was wondering, well, someone was wondering how MMC projects can be delivered in more built up urban areas. Is there perhaps a comparison program cost as well between traditional and modular from a project's inception? This is with regards to transportation challenges on roads, particularly with the large size of modular components?
Okay, so that's probably back to you, Owen, then. Again, what are you finding? Are there certain sites that are just too small and too contained and you avoid? And if so, where is the cutoff?
I think coming back to the overlay that Nigel showed on the DFMA overlay on the Reader Plan of Work, I think we've had to tailor our development process. So actually access is one of the first things we look at a land opportunity stage. So making an assessment as to what we can and can't get to a site is the sort of key question number one, really. You'll also have noticed, as you saw on my slides, our apartment modules are smaller than our house modules. And that's generally to cater for the fact that an apartment product is generally more suited to an urban setting where there's more constraint potential than a more suburban setting, which the houses are more aligned to. But yeah, I think in broad terms, we have looked at sites and the logistics challenges do become a constraint for a volumetric delivery. And that's where the different categories become important.
Thank you for that. So, Jason, we've got time for a couple more questions. What else
Sure.
have you got for us?
Sure, we actually have a question on slate. Slate is loved for being a traditional material, but how is its procurement, be it sourcing and delivery, being integrated into contemporary construction methods?
Okay, Terry, it would be remiss of me not to throw that your way. So do you want to run with that, please?
Yeah, that's fine. I mean, yes, it is a very traditional material. It's been around for centuries. It is used on quite a wide range of buildings. Some very old school traditional type of finishes, you know, in the countryside or barns in the middle of fields and so on. But then also in some very contemporary modern styles within major cities, in city centres. So it's quite, I think a lot of it is what's going on behind the slate. So natural slate can be fitted on its usual sort of finishes on most of the time on timber battens and counter battens. Very often underneath that there are changes in the insulation materials. The underlays over the years have changed quite a bit. There's often new materials coming out, including nowadays fire rated materials, and also one of our companies that supplies timber roofing battens, for example, is also offering fire rated battens as well. So yes, although that final skin of natural slates is still the same natural slate made in the same way it has been for centuries, what's going on behind that is changing fairly regularly, actually. Even in the last year, we're introducing new materials such as the type of batten, the type of underlay to fit in with modern requirements.
Okay, thank you very much for that, Terry. A very comprehensive answer. Jason, can I go back to you? So
Sure.
are there any questions that are kind of coming up again and again and again from the audience?
So we have one actually, which was being voted as well, which I will mention. It regards circularity, particularly as it was mentioned as being an important issue for client, I think, Igloo. How did this inform one's decision making when identifying parts for a panelized system? And what were you looking for, and how did having such a system facilitate this?
Okay, well, Connie, that's obviously one for you, isn't it? And you went through at the start of your presentation that Igloo have this kind of very clear roadmap on circularity. Is that actually just a way of clarifying a kind of approach that we should all be practicing now, or is there something very specific in their approach?
I think it's something that we should all be looking at, and that is really important for every single construction project. I think in terms of the panelized systems, they're already quite good in terms of circularity because they're using recycled material in their manufacturing processes, and the systems themselves can be recycled and used for something else. So when looking at circularity, I think both light gauge steel frame and timber frame are probably both quite good systems. In addition to that, for the Vaux project, we looked at all construction materials really, and just tried to specify materials that can be reused and use low carbon impact.
Okay, thank you. Jason, we've got time for one last question, so make it a good one.
Sure. There's a question that says, I'm interested to hear you say that 3D printing is not really a thing in the UK. Why is this, and is this likely to change?
Oh, okay. So that was Nigel, wasn't it, when you held up the categories? Yeah, why aren't we using 3D printing? Surely we should all be using it. And why are we different from our international counterparts in that respect? Nigel?
Yeah, I don't know why. I couldn't particularly say why we're not using it for low rise. Obviously, it doesn't work for sort of urban settings where you need denser development, and you can't really go above maybe a couple of stories with 3D printing. But I think it's just less efficient, really. We just really haven't set up for it in this country, and we do have organisations like L&G who are doing perfectly well with Category 1 and the sort of things that that Connie was talking about with Category 2. So I just don't think we need it at the moment. I'm not sure that it has the efficiencies. So you'll see it being used in the States and perhaps in other parts of the world, but it's just not really picked up here, and I don't think we really need it at this stage. I mean, maybe in due course when we haven't talked about the platform approach. People may be aware that the platform rule book came out about 36 hours ago, which I think is going to lead us in other directions, and I think is also going to help with that circular economy piece as well to some extent. And it may be that we start printing components, but we're just not at the moment.
Okay, thank you very much, all of you. So that is it for part one. Before we bring it to a close, I'd like to thank our content partners, SIG, and all four speakers: Owen Phillips of L&G Modular Homes, Connie Yachinska from Procter & Matthews, Terry Fairfield from SIG, and Nigel Osteen from Hawkins Brown, for being so generous with their time and their expertise and sharing particularly the trials and tribulations that they faced. Makes such a difference, actually, when speakers are prepared to share the things that have gone wrong as well as the things that have gone right. It's really helpful, and we're very grateful.